Dear friends, we will see the answers for the questions which is in the chapter 12 of organic chemistry. So we have the 12.1 exercise and what is meant by the following terms and give the example for each reactions. So we have the questions of cyanohydrin, aldol, then acetal, ketal, and these kind of questions, listed questions, and we will see one by one. So we have the cyanohydrin. So cyano means cyanide group and hydrin means hydroxyl group. So cyanide and hydroxyl group is introduced in a aldehyde group, in an aldehyde. So this is the final product which has cyanide group and an alcohol group. So this is ethanol cyanohydrin. How it comes? This is an aldehyde, and in the mechanism how it becomes the pair of electrons, because oxygen is attracts electron, so it will have the negative symbol. So the both electrons shifted here, so the bond broken and it's shifted here, and the electron, as the electrons came to here, this becomes plus and this becomes minus. So oxygen becomes minus, carbon becomes plus, so plus charge. So here we will see, to introduce cyanide group we will normally use hydrogen cyanide and the catalyst is alkali and KOH. So CH3 HCHO, this is ethanol and acetaldehyde, whatever we can call. So the cyanide group which is HCN, so H plus and Cn minus, we just split it, and this Cn minus will attack to this. This is a plus, so normally the minus will be attached to the plus group, so this will be attached. So HCN will be directly joined with the carbon group, and the O minus is as it is until the H plus will join. So H plus will join to the O minus, this O minus, and it will become OH group. So by this way the cyanohydrin comes. So ethanol, the final product is ethanol cyanohydrin. We will see the exercise 12.1 acetal. The second one is acetal and hemiacetal. In the acetal, it means the carbonyl group. So the aldehydes are ketones. It will react with the alcohol groups, two molecules of alcohol group. It will form ether. Final product will be ether. So acetaldehyde dimethyl acetal, which is an ether product. So for the introduction, so the carbonyl group normally C double bond O, the one of the bond, that means a bond means two electrons, right? So the two electrons, as the oxygen attract the electron, so it will be shifting towards the oxygen, so it gets the negative charge, and the carbon group will get the positive charge. Same like here we have the acetaldehyde, and the electron will be shifting here, and it will make oxygen minus, negative part, and carbon plus. So in the carbon plus we will, and for the ROH, which is an alcohol group, you can say H plus and OR minus, this product ROR. We can split like this. So the plus compound will go to the minus, and the minus compound, the negative compound, will go to the plus. So C plus will attract OR. So C plus group, after attracting, the plus and minus sign will be changed. So COR, and the other part O minus, the O minus will be joined with the H plus. So OH, you will get CH3 OR and COH. So it again reacts with another molecule of alcohol, So I have written here for easy understanding. So in the alcohol group ROH, and with the already existing OH group, so the H2O molecule, HOH molecule will be going out from the reaction, and OR will be formed. So OR again OR in the product, OR, OR, COR. So this reaction will be happening in the presence of dry HCl gas. So the final product will be an acetal, and the intermediate product, which is after reaction with one molecule of the alcohol, the intermediate product is hemiacetal. So the fourth one is hemiacetal, which is here, and the second one is final one. So this is acetal. Actually, basically this is acetal. Same like acetal, the ketal will be formed as the reaction between the ketone reacted with the alcohols. So the 1 mole of alcohol is reacted with ketone, it is attached. The OR group will be attached, and in the OH group, so in the second step, the OH group I have written here, this OH I have ROH, it is written here. So this H2O will be going out from the equation. So as H2O, and the R will be attached here. So the final product is R, and then OR dash, with these R dash coming from the ether, from the alcohol group. So finally we get the ether group, and here also we have a ether group. So both ether groups, that is why we have the ketal name. So this is a typical reaction for the ketal, and we will have the special case ethylene glycol, which has two alcohol group in one molecule. So which is, this reaction is actually in your CBSE NCERT book. So in the ketone reacts with the ethylene glycol. So here one molecule of H2O will be going out, and then the ring like structure we will get. So R, C, R, then O, CH2, CH2, O. So this is a ring like a structure, and this final product will be ethylene glycol. It is derived from the ethylene glycol. So ethylene glycol ketal. Aldol. Aldol or aldol condensation, both are same. So what is mean by aldol is aldehyde and an alcohol group, aldehyde and alcohol group, that is aldehyde and alcohol group in one molecule. So that is aldol. So after that it condense together to form a ene and al, double bond and aldehyde group. So basically the aldehydes which has the alpha hydrogen atoms, So what is that? The aldehyde carbonyl group, the nearby one which should have the alpha hydrogen atom. It means the nearby the carbon should have some hydrogen molecule. The carbonyl group which is attached to the carbon, that carbon should have the hydrogen atoms, that is alpha hydrogen atom. So molecule should have alpha hydrogen atoms, will only undergo the aldol condensation. Other aldehydes and ketones does not involve in this aldol condensation. So we will see the acetaldehyde reacts with another acetaldehyde. It is also acetaldehyde. I have written for easiest way so understanding. So the acetaldehyde, now just we will put CH3 group, then it will become acetaldehyde. The CO group, that a bond will shift, the electron will shift towards the oxygen, so it becomes O negative, and the carbon will become C plus. So the C plus will be attached by the, and the another acetaldehyde molecule which I have broken as H plus and CH2 CHO. So that the CH3 CHO becomes H plus and CH2 minus CHO. So these minus group will come over to join carbon. So to join this carbon, so that the CH2 CHO, this comes from this one. So it joins here, and the O minus, it will be attached to the H plus. So O minus will become OH, and the C plus became attached, that CH2 CHO molecule has been attached to the carbon atom. So now it lose in this CH2 means 2 hydrogen. So in the 2 hydrogen, one of the hydrogen will be lost to form H2O. So one H, another H, so 2H2 plus O, H2O it becomes. That's why a double bond will be created between this CH and this CH. This H I have written here. So CH3, CH double bond, CH, CHO. This is but 2-ene. If you name this one 1, 2. So 2-ene, then al, which is a aldehyde. So 1, 2, 3, 4. That is why 4 carbon butane. So but 2-ene al. So this is the IUPAC name for that aldol. So we can write in another way. This is as per the mechanism, it comes like this. If you want to understand in a easiest way, I will tell you. I have written the acetaldehyde CH3CHO, which is the double bond, and again CH3CHO I have written CH I have broken 3 carbon hydrogen atoms and CHO. So CH3 CHO. Now in these 2 hydrogen plus oxygen, it gives 1 H2O molecule. So it will be going out from the reaction and it will get the double bond directly, which will be attached to the carbon. So it forms CH double bond CH and CHO. This is the same molecule I have written in a easiest way. The next one is imine group. The 7th question, imine group, and the 10th one is Schiff's base. We will see about this one. So the carbonyl group, C double bond O, and the NH2 and Ez. The Ez can be anything like hydrogen or R. If it is hydrogen, then NH2 plus 1H, so NH3, right? So like that. Then it gives the hydrogen plus oxygen, it will go out minus H2O. So minus H2O. This reaction will be taking place in presence of an acid. So and the final product will be C double bond N and the Ez. Ez can be anything like H or hydrazine or whatever. The first one is Z is H. So instead of Ez we will put H, and or also we can put anything. So here we will see acetaldehyde. So acetaldehyde reacts with ammonia. This is H instead of H. Instead of Ez we put H. So it is ammonia, NH3. Reacts together to form methyl. So this is aldehyde group and imine. So C double bond N, it means imine group. So aldimine. The product is imine group. So this is aldimine. The next one we will see about the Schiff's base, which is nothing. If we put the instead of Ez and if we put R can be anything like methyl group, ethyl group, or C6H5. It is phenyl group, whatever. So if we put R, C6H5, C double bond O, it is a benzaldehyde, and in this one R is again C6H5, so it is aniline. So it reacts with benzaldehyde and it is aniline or NH2, that is R. So R NH2 and this is benzaldehyde reacts in the presence of acid medium and it produces benzyl aniline. So this is Schiff's base. This is Schiff's base. See about the oxime. Oxime name came from the hydroxyl group. So for the Ez part, NH2 Ez part, we will put OH. So NH2OH means hydroxylamine. For the carbonyl group, acetaldehyde, An example, acetaldehyde reacts with the hydroxylamine, produce the acetal oxime, and the CH2O will be going out. This H2O will be going out, and the product will be acetaldehyde oxime, acetal oxime. Semicarbazone. So to form a semicarbazone, we need semicarbazide. So semicarbazide means NH2 NHCO NH2. It is an amide. NH2CO NH2 means amide. So we have, instead of Ez in this one, NHCO NH2. For the Ez, NHCO NH2. So NH2 NHCO NH2, which is semicarbazide. So it reacts with aldehyde, acetaldehyde, to form semicarbazone. So this arrangement, C double bond N and H CO NH2, this is semicarbazone. We have water leaving from here. So we will see about the 2,4-DNP derivatives. So dinitrophenyl hydrazine. So DNP derivative. Instead of Ez, we will have this group phenyl dinitro. So this, instead of Ez group, this will 2,4-dinitrophenyl hydrazine. So 2,4-dinitrophenyl hydrazine reacts with acetaldehyde to produce 2,4-dinitrophenyl hydrazone. So same thing, the H2O will be leaving from here. So to form this 2,4-dinitrophenyl hydrazone.